In this tutorial, we are going to model the same pipe with both SolidWorks and Siemens NX, so we can compare the modeling workflow of these two CAD softwares. So before we start, please subscribe to my channel for more SolidWorks and Siemens NX tutorial videos, and leave a like on this video if it helps you out. Let me know if you have any problems in SolidWorks or Siemens NX, and I'll be willing to help. Now let's begin. So we start off with SolidWorks. First, create a file, which is a part file, and this is our 3D modeling workspace in SolidWorks. We're going to be using these dimensions as guides to model the pipe. This is the top view, this is the section view on the front view, and this is the right-hand side view. We first create a sketch on the front plane. So you're first going to draw this arc and then connect it to the constructional horizontal line here, and then revolve this arc around the horizontal axis to get the outer pipe. Then you create a cut with the same revolve feature of this inner arc using the revolve cut, and then we add these 3 flanges and this extension, and then we create holes and add fillets, and we'll be done. So let's first create the center line. It will be horizontal for construction, and a midpoint line. Click on this midpoint, and the total length of the horizontal line should be 36. Next, you draw a 3-point arc. And you make sure the endpoints of the arc are on this endpoint of the horizontal line. So give them that relation. So press the Control key, click on these 2 endpoints, make vertical. Press the Control key, click on these 2 endpoints, make vertical. And then you make these 2 points also horizontally aligned. So press the Control key and click on these 2 points, make horizontal. And then you align the midpoints here also. You press the Control key, make vertical. Now the radius of the outer arc is 36. So this radius dimension is 36. And then the distance between this endpoint and this endpoint is 18. So half is 9. So use a smart dimension and dimension this point and click on this line. If you move your cursor here, you can dimension half, which is 9. But if you move your cursor outside, you can dimension the 4 diameter. So 18. And so we can see the sketch is fully defined. So we just add vertical lines to close out the shape. The sketch is still fully defined. So exit. And you use the revolve board's base to revolve this curve around the horizontal axis using an angle of 360 for a full revolution. Okay. Next, we cut out this arc also. So again, we create a sketch on the front plane. So we first get our horizontal constructional line and a midpoint line. Click on this midpoint. Then you get a 3-point arc. The endpoints of the arc should be on these endpoints of the vertical lines. The radius of the arc is 33. And then the distance between these 2 endpoints is 10. So half is 5. So click on this point and this line. Move your cursor here. You can dimension just half, or move your cursor outside and you can dimension the 4 diameter. I'll make these 2 endpoints of the arc on the same horizontal line. So press the Control key, click on them, make horizontal. Now the sketch is fully defined, so just add vertical lines to close out the shape. Now exit. And this time you're going to use the revolve cut. And you're cutting about the horizontal axis using an angle of 360. Okay. Next, we add this circular extension on the top. So we create a sketch on the top plane. Draw a circle and dimension it. So the diameter of the circle, looking on the section view, is 18 millimeters. Exit. And then take note, you made a sketch in the middle of the pipe. So looking at this right view, the distance from the middle of the pipe to the end point of the extension is 22. So we start the extrusion at an offset distance of 22. Reverse the direction and set the end points or in the end limits of the extrusion to up to next. Okay. Next, we add these two flanges. So with the extruded boss base, click on this face, make it normal. Add a circular flange, and the diameter of the circle is 36. And then you make this cut here also. So this cut has the same diameter as this inner circle. So just use convert entities and click on this inner circle. Exit. Now the direction is okay. And then the thickness of the flange is 5 millimeters. Merge results and okay. Then we add these 4 holes. So the hole wizard, we use a legacy hole. The type should be a simple hole. The diameter of the hole should be 4 millimeters and it should be through to the next surface. So set the diameter to 4 and the depth or the end condition, set it to up to next. I will specify the position of the centers of the hole. So click on this face and make it normal. Now first you're going to draw a circle. That will be the guides for where the centers of the holes will be. So looking on this section view, the distance between this point, that is this center of the hole, and this center of the hole is 28. So the diameter of the circle should be 28. Make the circle a constructional line. And then you place the midpoint of the holes using the point tool or the point command. Place the midpoints on these 4 points. Okay. Now we mirror this flange and the holes to this other side. You come to mirror the mirror face or plane. We use the right plane. So you've selected the holes already and you click on this boss extrude, which is the flange in the features to mirror. Okay. Next, you add this top flange. The top flange should have a diameter of 26. So with the extruded boss base, click on this face, normal. So draw a circle of diameter 26. And extrude down by a distance of 4. So exit. Distance of extrusion should be 4. Reverse the direction to go inside. Merge results and okay. Next, create this cut. So we can use a countable hole for this particular cut because it looks like a countable. So the countable diameter should be 18, the countable depth 2, the hole diameter 7, and it should be up to the next surface. So with the hole wizard, legacy hole, and the type should be a counterbore hole. The counterbore diameter 18, counterbore depth 2, hole diameter 7. Okay, so the radius is actually 7, so the diameter is 14. And the end condition of the hole up to next. Click on positions, click on this face, make it normal, and then position the hole in the center of this flange. Okay. Then the last thing we're going to do is to add these fillets. So the horizontal fillet should have a radius of 1 here and here. And then this fillet should have a radius of 2. So the fillets 2, use a constant size fillet. A radius of 1 at first. Click on these 2 edges. Okay. Again with the fillet 2 and a radius this time of 2. Click on this edge. Okay. The last thing is to change the appearance of the pipe. So click on this part in the feature manager tree. Edit appearance. Then we change the appearance. Click on this arrow. We're using a high gloss plastic. So this white high gloss plastic, double click on it. Okay. So that's how to model this pipe with SolidWorks. And now we model the same pipe with Siemens NX. So in the Siemens NX window, click on New, Model, specify a name for the part and a folder to save it. Okay. Now this is our 3D modeling workspace in Siemens NX. So this is how we are going to go about it. We are going to sketch this shaded portion, or just below here, this shaded portion in the section view, and revolve it around the horizontal axis to get the full base pipe. So we create a sketch on the front plane, which is the XZ plane. Okay. And we get the horizontal constructional line, which will be the reference line. And then place the midpoint of the line on this origin, make coincident. And the full length of the line should be 46. Now we draw a 3-point arc with a radius of 33 and another with a radius of 36. Change this radius to 33 and this radius to 36. Now vertically align the origin with these midpoints. So click on the origin and these 2 midpoints, make vertical. And click on these 2, make them horizontal. Again, click on these 2, make them horizontal. And the distance between the endpoints of these 2 arcs is 36. So the linear dimension these endpoints as 36. And then we vertically align these endpoints as well. Bring it down here. And then the distance between these 2 endpoints is 10. So half the distance from this endpoint to this center line is 5. And this is 9 because this is 18. The linear dimension, distance between this endpoint and this line is 5. The distance between this endpoint and this line is 9. So the sketch is fully constrained. So we add these lines to close out the shape. Okay, we use a profile tool. We'll close out this side also. And the diameter of this flange is 36. So that means the distance from this endpoint or this line to this center line is 36 divided by 2, which is 18. So the linear dimension, the distance between this line and this endpoint is 18. You make sure this line and this line is collinear. They will be on the same horizontal line. And the thickness of this flange is 5. Change this thickness to 5. Again, make this line and this line equal. So the sketch is fully constrained. Finish. Now we use the revolve feature and the curves to revolve. Click on this sketch. Okay, so we can see this line has also been selected. So click on cancel. Double click on this sketch to edit it and return this line into a reference line. Finish. So it won't be part of the revolution. So again, click on revolve and select the sketch. Come to this axis, specify vector. You're revolving around this x-axis. So click on the x-axis and then the point, click on this origin. Okay. Next, we add these 4 holes. So with the hole feature, it's a simple hole of diameter 4. Click on sketch section. Click on this face. Okay. Now again, we draw a circle. And the diameter of the circle should be 28. Change the diameter. The radius or the diameter should be 28 actually. And turn it into a reference line. So click on the circle and go to reference. And with the point tool, place the 4 points on this circle. And we have to align these holes. So right click, select from list, click on the point, right click, select from list and the point, and then click on this origin, make horizontal. We do same for these 2 points, but this time vertical. So right click, select from list, points, right click, select from list, points, click on the origin, make vertical. So the sketch is fully constrained, exit or finish. Okay. Now we mirror these 4 holes onto the other side. So locate the mirror feature. You can search it in the command finder if you can't find it. Click on the mirror feature. Features to mirror, click on these 4 holes. And we are mirroring using the YZ plane as a reference. Okay. Next we add this extension to it. So we create a datum plane at a distance, and the datum plane should be similar to this XY plane. And the distance from where the datum plane is to the one we are creating is 22. Okay. So we extrude, sketch section, click on this datum plane. So the circle would have a diameter of 18. Finish. Then you're extruding downward to reverse direction and the end limit of the extrusion to until next. Set the boolean to unite, apply. And create the flange. So again with the extrude feature sketch section and click on this face. Okay. The flange has a diameter of 26. Finish. Reverse direction. And then the thickness is 4. Set the boolean to unite, apply. And then we create the first hole of diameter 18 and a depth of 2. So again with the extrude feature, sketch section, click on this feature on the flange. Okay. So the circle should have a diameter of 18. Finish. So reverse the direction. And the depth is 2. Set the boolean to subtract. Okay. And we add this hole also with a radius of 7, hence a diameter of 14, and a depth until next. So again with the extrude feature, sketch section, click on this face. Okay. Run a circle of diameter 14. Finish. So reverse the direction, set the boolean to subtract, and the end limits until next. Okay. Then we add the fillets. So the edge blend, the radius of 2, click on this edge, apply. And again with the radius of 1, click on these 2 edges. Okay. And then finally, we change the display by coming to view, through shading. The global materials, we set it to white glossy plastic. Then we can finally hide these sketches and the datum planes. So click on the sketch, the datum plane, and datum coordinate system and hide. So now you can save your file. Okay. So yeah, that's how to model this pipe with Siemens NX also. You see the differences in the modeling workflow of these two CAD softwares, SolidWorks and Siemens NX. I hope you like this video. Make sure you hit the subscribe button and turn on post notification, and leave a like on this video if it helped you out. Thanks for watching, and I'll see you in the next tutorial.